So this is our first equation, y equals 2x squared minus 5x minus 3. If I want to find the x and y intercepts, first off, if I want to find the y intercepts, how do I do that? Right, good. So y intercepts are when x equals 0. So y intercepts, that is when x is equal to 0. So for this equation, when x is equal to 0, I've got 2 times 0 squared minus 5 times 0 minus 3. So what is the y-intercept? Negative 3. Okay, so that is 1 point. For the x-intercepts, I need to make y equal to 0. Good. Y-intercepts, that is when y is equal to 0. So 0 equals 2x squared minus 5x minus 3. Now, last time we seemed to have a lot of difficulty trying to factorize this. So how do we go about factorizing something like this, Marco? Okay, good. You want to split the middle term. So I want two numbers that multiply to give negative 6, because it's 2 times negative 3. The same two numbers have to add to give negative 5. Those two numbers are negative 6 and 1. That makes sense. Negative 6 times 1 is negative 6. Negative 6 add 1 is negative 5. So we take our two numbers, and what do we do with them? Anyone else? Right, yeah, good. Put them in the middle with an x. So I've got 2x squared. I'm going to have... Does it matter which way around I put them? It does not. Good. What do you do after you put them back in? Factorize. Okay, so I'm going to factorize the first half. So what can I take out as a common factor? So I've got x minus... What do I do after that? Yep, factorize out the other part. Now, what do I know about this bracket and this bracket? They have to be the same, so I just write this straight down, okay? And then what in here multiplied by this gives me this? Yeah, it has to be a plus 1. So when I factorize it, I am getting 0 equals 2x plus 1 and x minus 3. So that means what? Right, either this part equals 0 or x minus 3 equals 0. In which case, x is equal to negative a half or x is equal to 3. Okay, so knowing that information. Okay, now the last part of this question was that we have to graph it. But if I want to just quickly do a little sketch, actually I asked for a sketch, I didn't ask for a full-on diagram, just one sketch. I know from the information that I've got already that the x-coordinate is negative a half. It also goes through 3, and it also goes through 0, negative 3. Is this a happy or sad face? A happy face, because... No. Why do I know looking at this equation that it's a happy face? Because it's positive x squared. Okay, so it's going to go down like this. Boom, 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 and through there, okay? Nice, smooth, smiley face, okay? Is everybody okay with that? Yeah. Alright, then using the quadratic formula, that was the next part, just to verify these. So this hopefully should have presented no problems. So we've got minus b plus minus square root b squared minus 4ac. What is b squared minus 4ac also known as? Good. b squared minus 4ac is the discriminant, which we will talk about today. In our equation, what is b? Negative 5, so it's negative 5, which is positive 5, plus or minus the square root of So negative 5 squared, which is minus 4 times 2 times negative 3, all over 2a, which is 4. So 5 plus and minus. Now what am I expecting my answers to be for this? Like, what answer should I get for x here? Alright, negative a half and 3. Okay, I should get the same thing out, okay? 25, what is this? So 3 4s are 12, 24, 49 over 4. So this is 5 plus 7 over 4, because the square root of 49 is 7. 4, 5 minus, oops, back up. 5 minus 7 over 4. This gives me a value of 12 over 4, which is 3, or negative 2 over 4, which is negative half, which is what we expect. It's exactly the same as this. Okay, remember, this is the expression, more than one way to skin a cat.
Please don't use that one.
Okay, so who did that? Ellie, did you get down to there?
Yeah, I did it. I just got it wrong, so.
What's your quadratic formula bit?
Yeah, I did something. I don't know.
Did you use your negatives correctly? Okay, so the discriminant is b squared minus 4ac. So in this example, what is b squared minus 4ac? Which is 49. Which I'm not going to comment too much on it now because I'm going to look at the other examples first. But we notice that this is a, yep, and it's also a positive number. That's all I'm going to remark on it, and we'll come back to that, okay? Right, vertex form. Kate, did you do that okay?
No.
Yes
This was
and
the
no.
only one that I got. This is the only one I got wrong. The other ones I got right.
Right, so I've got 2x squared minus 5x. Take away 3?
Yeah.
If I want to put this in vertex form, first step is to
Oh,
factorize out the 2. And I am going to leave these as fractions. It will make it easier. That is my first step. So remember, in vertex form, it looks something like something else, okay? So some number multiplied by x minus b squared plus some other number, okay? It has to be of this form. So first step, take out 2 as a common factor. What's your next step? Nope. Nope. Just to make it easy, just for my sake, to make it easier to see. Okay, it doesn't matter whether you use square or... What do you do next? Right, half the middle term. So the middle term here is 5 over 2. I'm going to half it. What's half of 5 over 2? 5 over 4. I'm going to add on half the middle term, but you have to
Yeah, I didn't know what happened.
square it. And then I subtract it off again. Okay, and I've still got my minus 3 over 2. So if I quickly look, my middle term is 5 over 2. And if I want to half my middle term, I'm multiplying it by half. Okay, that's half my middle term. Or, yes.
Are there examples of, I guess, Vertex Form and like stuff online so we can try it with the computer?
On what kind of, like, I mean, different software, or?
Yeah, do you know, because you know there's math genius or whatever, and you like do questions and stuff, and there's like tests online, because with the ESS one, like I want to be able to practice
Yeah.
putting in.
Oh, we can have I'll have a look, okay? But the thing with these is you can make these up and work them out, and then work back to see if you actually get back to where you started from. But we'll have a look for online ones as well. So our next step, these three terms collapse into, this is going to be x, and I'm going to have, it's take away, take away, take away, so it's going to be take away, and 5/4. If I was to expand this, it gets me back to these three terms. Okay? I've got then, take away, what's 5 squared?
25.
What is 4 squared? Minus 3/2. So I now need to combine these last two terms. Oops, that's number 16. So if I want to make this one over 16, what number has to go on top?
3 times 8.
Yep.
Yeah.
So I've got 2, big bracket. Minus 25 take away from 24 is minus 49/16. And then to finish it off, we multiply through by the 2. So that gets me 2 bracket x minus 5/4 minus, what's, oh, sorry, squared, thank you. Minus, what's 2 times 49/16?
Double 49.
But you could do that, or you could just 49/8, okay? Alright, so this is our vertex form. What is the vertex then, looking at this?
5/4 -9/2.
Good, you take this one, you change the sign, and you leave this one alone. Looking at our graph, so I've got 5/4. 5/4 is what as a decimal? 1.25, sorry. So 1.25 in here somewhere, and again, so this graph actually probably comes a bit further down. We'll draw it again. Okay, so 1.25 and negative 49/8, which is what, Kate? 6 and 6. Okay, so my sketch is a little bit off, but we can redraw it. Okay, we'll redo that in a second. Okay, so yeah, we'll just redo the sketch down here. I'll do it over on this side. Woo, nice.
That was beautiful.
Yeah, check that out. Okay, so I'm looking for not a work of art. Okay, so my x coordinates are -0.5. This one is 3. My y-intercept is -3. and my vertex is 5 over 4 negative 49 over 8. Okay? As long as you put, okay, you try and make it as symmetrical as possible, but as long as you put all your intercepts in, your vertex, you're good. Okay? And just remind me, what did we note about the discriminant? It's positive in this example, okay? Any questions on that? Right, what was the next one? The next one's actually is slightly easier, 4x squared minus 100. So again, who had a go at this? I've done our y-intercept, our x-intercepts. This is what I'm working out now. X-intercept is when y is equal to 0. How do I go about factorizing this? This is something that you should all be able to do easy. Yep, Marco? Right, no, but this... Okay. Now, there's an easier way to do this. He's saying that we could split the middle term, but there's an easier way to do this. I'm not dividing by 4 because I want to factorize it. If I divide by 4, I'm changing the equation. I factorize out 4. I end up with x squared take away 25. Now this should be something that you recognize. X squared minus 25. What do you notice about those both? They're perfect squares, right? And I'm finding the difference of them. So what I can do is right, x plus 5, x minus 5. Factorized, okay? This is called difference of two squares. You should always be looking for this type, okay? So if all these things, if this equals 0, then x is equal to either, well, negative 5, because that would make this part 0, or x is equal to positive 5. Yep. Are we following?
Yes, we are.
So my x-intercepts are 5, 0, and negative 5, 0. Yeah?
Yes.
Again, this is the third way of factorizing. Difference of two squares. Alright, now if we had to use a quadratic formula, x is equal to, what's b? And we'll start off, what's a?
4.
b? c? So I've got x is equal to negative b, so 0, plus and minus the square root of b squared minus 4 times a times c, all over 2a. So I end up with plus and minus the square root of 1600 over 8, which is equal to positive 40 over 8 or negative 40 over 8. So again, x is equal to positive 5 or x is equal to negative 5. Okay, so you get the same answer. Now the point of working, I want you to work this out because what do we notice about the discriminant in this case? Okay, the discriminant b squared minus 4ac is equal to 1600, which again is positive. And it's going to be a smiley face. Okay, now the vertex form. So remember, vertex form Nelly, tell me what letters I use for vertex form? Like the general, you wrote it in your book. Okay. Now, looking at our original equation, we've got 4x squared minus 100. What do we notice between these two things? Yeah, it's exactly the same. What is A?
4.
Yep. What is B?
1.
No.
No, 0.
0, because what we've got is x minus 0 all squared, and C is, yeah, okay, so this is my vertex form. So my vertex is 0, negative 100. So when I come to draw it, my curve is coming down like this. That's a bad looking curve. I'll try that one more time, make it a bit better. Okay, and it's going through negative 5, positive 5, and my vertex is on the y-axis.
So what, number 3? 8? Yeah. 8, 9. Yeah, but it's, yeah, no, it's positive.
Can I factorize it?
No, it's not, it's negative 11. No, it's positive. It's positive? Positive. Because if you sub in 0 for x, then it's y equals 11. It's 2x squared minus 5x plus 11.
Oh, plus minus 11? My bad.
Is it?
Yes.
Okay.
Are you sure?
Yes.
I looked at the video.
It's minus 11.
It's plus.
Is it
I
plus
looked-
11?
yeah.
Sorry.
Okay, fine. I feel like there's an evil scheme, but okay.
Sorry. I'll go back in a second and just check that out.
I looked at
I didn't put it in my book.
Sorry, I just wrote that wrong there, did I?
yeah, and it's identical. So I can figure out.
Yep, plus 11, yeah. Can you factorize it?
No, you need to find the y. First, so we have to do y equals 2 times 0 minus. Okay, so basically y is 11. So that's the 1.
Yep.
0. And there is no
Can we factorize it?
no.
Okay, we can't factorize. There's no two numbers going to multiply to give 22, but add to give negative 5. Okay? The other way we could try and work it out is to use the quadratic formula. Minus b, so that's minus 5. 25 minus 4 times 2 times 11 over 2a. What number does that give me underneath the square root?
Negative 63.
When you put negative 63 into your calculator, it says error. Domain error, okay? We cannot
So whenever I have that,
find
there's
the square root of a negative. So we said, this is important if you didn't write this down, so write this down. So there are no real, what's the other word I used for the x-intercepts? Roots. So there are no real roots. If there's no real roots, there's no real numbers that this graph cuts on the x-axis. So that means that, does it cross the x-axis?
no.
No, it does not. Okay. So it's going to be above the x-axis. Alright, we know that it goes through 0, 11. So it's going to look something like that. Okay, but it does not cross my x-axis. Now I can still find the vertex by putting it in vertex form. Oh, and just let me know, what do you notice about the discriminant in this one? Right, the discriminant is negative. The discriminant is negative. And if it's negative, what else do we notice about it? There are no real roots. When the discriminant in the other examples, what did we notice about it in the other examples? It was positive. And how many real roots were there in each of those ones? Yeah, there were 2 real roots. So what is the discriminant telling us?
Oh, I remember the number of
Right, the discriminant tells us the number of roots that there are, okay? Now there's another case that we can look at. We'll look at that next time, okay? But we'll come back to the discriminant next time, okay? Right. Okay, we'll look at the discriminant again next time.
But that would mean that it's not
That would mean what, sorry?
wouldn't it not be like
Right.
I mean, yeah, not a function because it'll be this.
Well, no. They all look like this or like this. Okay? So if it's got no real roots, it's above the x-axis, it doesn't cross it. If the discriminant is positive, it's got two real roots, just like the ones that we did. Right.
Okay, so it's just the vertex.
Right, yes, okay, but we'll talk about that next time, okay? Make sure we all put this in vertex form. Okay? You've got 5 minutes. I'll start you off if you're still not sure. Put the 2 aside. Excellent. What do you add on them? Subtract? Yep. And don't forget that you have to square it. The good thing about these is as well that you know that whether you've done it right or not, because it's all to do with the shape of this graph. I know that the vertex has to lie in this quadrant, okay? Or in this one, but it can't be a negative number, okay? This y value cannot be negative. It has to be positive, because if it's negative, the graph is going to cut the x-axis, okay? The good thing is I can check this, okay? Because I know, because this graph, this quadratic, does not cut the x-axis, yeah? The vertex has to be positive, okay? This, no, just for this one. Please go through this, okay, and have a look at it again tonight.